Hi guys, I'm going to go over the worksheet which is in Google Classroom about the chi-square. So let's start with what is a chi-square. So chi-square is a statistical test used to see if observed values for the set of data are similar to or significantly different from expected value. So you should have two values. One is expected value and the observed value. So in case of genetics, we are looking for the expected value from Mendelian genetics. So I'm going to go over more in detail about that. Now chi-square is also a tool for hypothesis testing. So we have two types of hypothesis, the null hypothesis and the alternative hypothesis. So when we run the chi-square and there is no, for null hypothesis, if there is no significantly difference between the observed and the expected value, then we can reject the null hypothesis. So that's how we do that. I'm going to talk more in detail about how to test for or how to run the chi-square for testing the hypothesis. But right now, let's go over this worksheet and let's see how we are going to prove that if the observed values for the set of data are similar or significantly different from the expected values. So Uh, the expected values, that is what are going to be expected from the Mendelian genetics, that is when you do the Punnett square, you get the expected values. And the observed value are already given in there, or the observed value are also the data which you get after doing an experiment. So there can be a difference between observed value and the expected value. There can be different reasons. One is it can be due to random variation, or if there can be some experimental data errors. So let's look at that. So for this, you need to have two things. One, the chi-square value, which we are going to calculate, the chi-square value. And the second you need is the p-value. So the p-value is a number between 0 to 1. So when the p-value is large, that means you can have two options. One, large p-value, then the chi-square value, no difference between observed and expected value. So there is no difference between observed and expected value. But if the p-value is small than the chi-square value, then there is a statistically significant differences there. So in that case, there it can be due to random variation, or it can be some experimental errors. So now let's see how to calculate chi-square and the p-square. So when you compare both of them, when the large value, when the p-value is bigger than the chi-square, there is no difference between the expected and the observed value. When the p-value is smaller than the chi-square value, then there is a statistically, just omit my spelling mistakes. So if the p-value is smaller than the chi-square value, then there is a statistically significant difference in the observed and the expected value. So let's start with this. In this, we are taking a genetic, that is problem from Mendel, and it says in a pea, yellow seeds are dominant over green seeds. In a cross between two plants, both the heterozygous for seed color, the following was observed. So these are going to be our observed value. And let's see how we are going to calculate the expected value. So it says there is a cross between the heterozygous. So we are going to take this A, and cross between A, and you're going to draw the Punnett square. So when you draw the Punnett square, so what you're going to get is a ratio of phenotypic ratio, that is 3:1. That means there will be 75% of the yellow seeds and 25% are going to be green. So this is going to be our observed value, but we need to give, let's write down here the phenotype. What we are looking at is the yellow, and the other one is the green. So the observed value for yellow is given is 4,400, and green is given 1624. So already have done the totals with some of the girls who came for tutoring. So the total is going to be 6024. Now we need to have numbers rather than percentage here. So we know yellow is going to be 75% and green is going to be 25%, but we need some numbers to write here, not the percentage. So we are going to calculate the numbers from these percentage. So the yellow should be 75% of this total. So that means we are going to do 6024 times 75%, and likewise we're going to calculate the 25% of the green, which is going to be 6024 times 25%. Let me use another color. So this expected value is going to be 4518, and for green is going to be 1506. So when you subtract the observed value from the expected value, here you're going to get it is negative 118. And when you do this, again, you're going to get is positive 118. Now, when you do the whole square for this, you're going to get a number which is going to be 13,924. And for this also, the number is going to be 13,924. So you're going to divide this number by the expected number. So you're going to divide 13,924 by the expected. You're going to get is 3.08. And now you're going to divide the expected value, which is 1506. 13,924 divided by 1506, you will get a value of 9.24. Now add them all and you're going to get 12.32. This is your chi-square value, the chi-square value. Now you need to compare this with the p-value. So how to calculate the p-value? Now, to calculate the p-value, you need to know two things. One, that is we are going to calculate is the degree of freedom. So the degree of freedom is calculated by n minus 1. So what is n? N is the number of categories. So how many categories you have? So here we have two categories, that is yellow and green. So the degree of freedom is going to be 2 minus 1 equals 1. Now this degree of freedom we are going to use to calculate our p-value. Now for this we have to look for our, let's see, where is the significance table. So there can be so many other numbers in here in the column, but you're always going to look for the significant table for 5% probability value, or which is 0.05. So look for this column. If there are many columns in there, just look for this column, which is significance table or the probability value for 0.05. So in this class or biology, or even for your IA, you're looking for 0.05 p probability or value, that is p value. Now you have to look for the degree of freedom. So we calculated a degree of freedom that is 1, and look for what is the probability value for degree of freedom, that is 3.84. So for our p-value from this chart is going to be, p-value is going to be 3.84. Now if you see that our chi-square value, there was 12.32, which is bigger than our p-value. This is 3.84. And if you go on the top, what I have written is, if the p-value is small, then there is a statistically significant difference. So we can say that no, the data does not fit into the predicted phenotype. No, the data does not fit into the predicted phenotype. That means there is a statistical significantly difference. It might be, there must be random variation, or there is experimental errors. So we are going to say that the data does not fit in the predicted phenotype. So I'm going to talk about how you can use the chi-square in hypothesis testing, but you can use this video to solve other problems in the worksheet. So hope this works out for you.